ready? Ready? So today's going to be pretty easy with this matrices because we're just going to be adding and subtracting. Okay? A matrix has rows and columns, and eventually what I'm going to show you how to do, the best use of matrices is solving simultaneous equations. Everything that I'm making you do by hand, I'm going to show you how to do it on your calculator using matrices. So that when you get to ACTs and SATs and they give you simultaneous equations, you don't have to struggle through physically working it all out. You'll be able to save some time and do it on the calculator, okay? But we have to understand how matrices work before we just go ahead and let our calculator do all the work for us, okay? So I'm going to show you how to do some manipulation with these matrices. Now, matrices have these little hooky things that surround the numbers, okay? They have elements, 2, 3, 4, 6, 8, and 10. We define matrices by the rows, and if you think of rows, you know you're going across. So rows go this way, and columns go up and down. So columns are what holds buildings upright, and so we think about them as going up and down. So when we define a matrix, which we're going to call in this case A, we name it first always by the row and then by the column. The order is really important that you understand. It goes row and then column, not column and row. Okay? First the row, then the column. When you are adding matrices or subtracting, doesn't matter, the rows and the columns have to have the same amount. You've got to have the same dimensions, number of rows and number of columns in each of your matrices. Okay? So if I have, this is a 2 by 2, and this is a 2 by 2. I have 2 rows and 2 columns in each of my matrices. Okay? The way we figure out what the sum of those matrices are by adding the individual elements. Now, we have to get them in the right spot. A can only be added to E because it's the first element in each row and each in the column. Does that make sense? C can only be added to G. B can only be added to F, and D can only be added to H. Okay, and so that's what I'm telling you right here when I'm setting up this example. So, what are the dimensions of this? So, we do rows. How many rows are there? There are 2 rows, and how many columns? 3. In this case, how many rows? How many rows? How many columns? So will each element have something to add in the other matrix? Okay, if it doesn't, you can't work it. Okay? All right, so that means I'm going to add the 6 with the, and I put it in the first spot. I'm going to add the 3 with the, and I'm going to put it in the second spot. I'm going to add the 4 with the, and that's going to go in the third spot. Okay? And now, what am I going to add this to? I'm going down to the next row, so I have to go down to the next row in my answer. What do I add the 2 with? What's that? Okay, we don't not put anything in there. We put a value of some sort. What do I add with the 8? And that's 3. What do I add with the 1? And so I get 5. So my answer matrix is going to be also a 2 by 3. It's going to have the same dimensions as the 2 individual ones that I added together. Does that make sense? Okay. Yes? If the dimensions are the same, yes. Your dimensions must be the same if you're going to add. All right, so subtracting. Order is really important with matrices. You do the first one minus the second one. You can't flip-flop them around, okay? So if I have elements of A, C, B, D minus X, W, Y, Z, then it's going to be A minus the X, C minus the W, b minus the y, and d minus the z. Okay? So what are the dimensions of this one? This is a what? 2 by 3, and this one is a? Can I subtract those two matrices? And how many rows and columns will my answer have? It'll be a 2 by 3, right? Okay, so now let's do it. Now, the funny thing about subtracting is we have to be careful about our signs. Okay? So 6 minus negative 2, right? So that's 8, right? So I'm going to kind of, let's see. Well, I'm going to show work, but you can do it in your head. Okay? Then I'm going to go 3 minus 0, which is, and what is that, a 0? 0 minus 4, which is negative 4. When you do your matrix, when you do your answer, you've got to have those little hooky things around them. Okay? All right, the next one. It's going to be 2 minus 6, which is negative 4. It's going to be negative 4 minus 2, which is, and it'll be 8 minus negative 1, which is, what is my error going to be in doing this? Yeah, I'm going to go 8 minus 1, and I'm not going to do a double negative, right? So I'm not really going to be adding. I'm going to be subtracting. Okay. Can I add these? What is the dimensions of this? 3 by 2, and this one is a 1 by 3. Can I add these? No, the dimensions are the same. Nope. Or no. Yeah, and in this case, and I'm always going to say, if the answer is no, tell me why, because I don't just want you to have a 50-50% chance of getting it, and so you would have to say the dimensions need to be the same when I'm adding or subtracting. Okay. So here we go. This one didn't really work out right, so let's see if I think I have a different one. Is there one on the next page? I'm trying to show you how to do this one, but okay. For argument's sake, if this had been a better example, let me show you what I wanted you to do. Okay? See this little 2? That's a multiplier. It's like if I'm going to go 2 times 8. Okay? It'll just increase everything that's in there by 2. But matrices follow the same rules that order of operations do. We do what's inside our parentheses first, and then we worry about our multiplication and division. Okay? So I have a 2 by 2. Would you agree? And this one's a 2 by 2, correct? So I need to add these two before I worry about this 2 that's coming out over here. So what is 5x plus 3? Well, it's just 5x plus 3, isn't it? What is negative 2 plus 7? That's going to be a 5. What is 6 plus negative 5? 1. What's negative 4 minus y? It's just going to be negative 4 minus y, isn't it? Now, all of this is supposed to equal negative 21, 15, 3, and negative 2, which happens to be what dimension? The answer matrix is what? 2 by 2. And this one is still what? 2 by 2 also. Okay? Now this 2 takes this value and multiplies it by every single term in here. So we're going to pull it in. We're going to say then 2 times 5x plus 3. And then 2 times 5 is 10, isn't it? And 2 times 1 is? And 2 times all of this is We're just going to leave like this. All right, remember, I didn't have this set up very well because I would have liked, what should have happened here, this should have been a 15 and a 3. But for argument's sake, just so we go through the process, this answer matrix means that twice 5x plus 3, what does that truly have to equal? It has to equal 21. And twice negative 4 minus y has to equal, because those are in the same positions in both of the matrices. Does that make sense? Okay, so although these didn't work out right when I came up with my example, they should have been 15 and 3 to be a true 1-to-1 type of ratio, okay, or example. So then in this case, we would say, well, that means 10x plus 6 is equal to 21. So 10x is equal to 15. I'm just solving, right? Oh, was it? Oh, thank you. And so then what do we really get? We get negative 27, right? And so negative x is going to equal negative 2.7. Are you okay with that? Because I'm going to divide by 10. And then y, I'm going to say negative 8 minus 2y is equal to negative 2. Negative 2y is equal to what? So y is equal to negative 3. So the process that we did, does that make sense? How we're going to simplify those two matrices and multiply all the terms by 2 and then locate which elements are going to match up to come up with an equation. That's the process that I wanted you to know. Okay. This one should work. Why don't you try this one yourself? I think this one will work. It's a better example. Oops. To see how this one works the way it should be? In other words, this is 10 and so is this one, right? That they match up. And this is positive 2 and so is this one. So that means we should set 6x minus 18 equal to what? And negative 2y minus 6 equal to negative 18, I think, right? And so this gives me 6x is equal to 30, so x is equal to And here we get negative 2y is equal to negative 12, so y is equal to 6. How'd we do? All right, yes? Either one. Either one. Okay, so you try this. Pair up with somebody. Do you have this page? Okay. Pair up with someone. Move your desks and work them together. Okay, so how do we do? Did you get it right? 18, 1, 14, negative 6 for A plus B. 4, 8 told you to multiply everything by 4. So 24, 16, 32, and 8. Right? Show me some work on this last one. Tell me what 3C and 2B are. Write those matrices down and then tell me what 3C minus 2B is. Okay, so you've got to show me a little bit of work on some of this. Okay, anybody got a question or didn't get it to work?
So you don't distribute the negative sign through?
I did when in my head, I did 3 minus 24. And then I did 0 minus negative 6.
Do like the 2.
Oh, no.
So we just do the best.
Yeah. Yeah. Okay. Anybody else? Oh, Riley. Next, previous page, uh-huh.
You're multiplying. So like when it's like 6x minus 18, how do you leave it like that and then take the final thing and add that in there? Or I'm just kind of confused where you're trying to get mixed up.
How I got 6x minus 18?
No, like how I understand how you get that. How do you get from 6x minus 18 to multiply the 2 to the negative 18?
But that was given to me.